Jeff, you showed us some pretty spectacular projects there with facades that respond to the environment and to the requirements of the buildings. And you showed very advanced use of parametric design tools. So one question I had was, what is your experience? What are your thoughts on the ownership of all that information? You're generating this information as you develop your early stages of design, so these are actually digital sketches in a way. And I would have thought that by doing so, you actually attract a lot of responsibility. You start to look at the energy concept of the entire building skin. And in my experience, there's a risk that you are stepping on people's toes. So can you comment on that?
Sure. Is this on? Yeah, good. Data-driven design methodologies don't just make buildings perform different or look different, but they do restructure how we design. It restructures the teams. In fact, fundamentally, it is a much more fluid, dynamic, collective enterprise. And so there are risks associated with it, certainly, and more so in places like the United States than perhaps others. But in order for us to reap the benefits of it, I think we have to dive into that somewhat risky environment and together as a team collectively own the information, to embrace each other's contribution to that data set, and to find a way to resolve these issues of liability in a more mutual environment. That being said, there's certainly a lot of all of our practices certainly contribute intellectually to the process, and I do think process is something that each consultant, each designer, the client owns. The data itself, I'm one that would say that the data itself is to be out there, to be used, and to be leveraged to its fullest ability. I'll leave it at that. Thankfully, I'm not a lawyer.
We will have more time to discuss towards the end of the session, so please.
Moshe Tzur, architect from Tel Aviv. About the stainless steel cladding for the facade. What are the difference in cost with the better alloys than the 316L, and what cleaning cycle it demands for keeping it well? And is there availability in the composite panels of the better steel alloy, like Outokumpu and Renobond?
So let me first answer the question. The 316L, usually we recommend a yearly based cleaning interval for the facade.
I'm talking about Middle East.
The what?
I'm talking about Middle East.
Middle East, 316L every second month for 316L. And as I said, the 2205 probably then once a year with that alloy.
And
the cost, well, I'm not a salesperson, so, well, of course, the 2205 is a little bit more expensive, but you've seen that in the diagram, the alloying elements are not so much different. It's a duplex material, so it has another grain structure, and we have other corrosion. The composition is different, so the resistance is based on different physical.
So it's approximately 20% additional cost?
No, I wouldn't say that.
So how much?
But you can. We have salespeople actually in our booth, so you can go there and ask them for further information about that.
Okay.
About
the composite panels?
Yeah. Right now, the composite panels are available on austenitic grades only, but so that wouldn't be available on the duplex material. But that's an issue that the composite manufacturer have to solve these issues. probably that might be available soon. Well, what also might be a problem, the duplex cannot be rolled down to 0.3 or 0.4 millimeters. So, and then with a nice pattern. So, could also be a challenging issue.
Our question is, you gave us an example of a shadow box, and one of the examples that you showed us was with a double glazed external skill assembly. Now, in your assessment or all the cases that you've been studying, have you come across any performance differences when we do replace that double wall glazing on the external skin of the shadow box with, say, a metal composite panel?
For this particular study, it was not quantified. It has been run in other sequences and other variations, and it does show that it is higher thermally transmitting, therefore less thermally performing. So there's a higher transmission in metal components. Now, that having been said, I do recall that run was based on a 3 millimeter solid plate, and you bring up an interesting exploration with the consideration of composite panels as well. I would expect it to have a similar type of characteristics, probably not that profound.
I mean, typically, are you looking to look at such shadow boxes as self-contained, thermally insulated, which don't sort of penetrate into the area, or do you did mention that philosophical question, venting it? How do you actually look at it in terms of treating it in with respect to thermal insulation?
Yeah, that's a philosophical discussion bordering on Nietzschean. So in the greater context of the whole thing, it can be vented or non-vented. We're not talking about a technical preference or technical leaning one way or the other. It is purely from the perspective of U-factor conductance transfer back and forth. Now, if you vent, there's definitely going to be a convective component that's going to be involved in that. But with that convective component, again, we had discussed in the slide set, there are dust issues, there are VOC accumulation issues, and when you vent and you introduce it, are you actually doing a better job at evacuating it if you vent it properly, if your vent holes are big enough? And then we start getting into another philosophical discussion of pressure equalization and the difference between pressure equalization and pressure moderation. So, I mean, we can really kick this discussion into a very wide and broad band of topics. But I think to try to keep it focused, it's about the thermal conductance or thermal conductivity values and contribution of advanced materials and the very specific collaborative application of those advanced materials that we're talking about.
When using copper and also corten steel, and if I'd like to stop the corrosion and not coming to the greenish color, can I stop it with lacquer coating on the to maintain the yellowish red color? And can we do the same with corten? Because corten maybe it spills off and the lacquer will not stand on it.
To answer your question, the 60 Queen Victoria was a great example of stopping the copper patina at a certain place. So for a fact, it can be done with copper. You can also stop it at the other stages. You can keep it with the brownish color at the various stages. So that is true. Your second question was corten. To my knowledge, there's not a method for stopping corten. It's a little different. It's a patina, but it's a corrosion.
It spills off, yes.
Yeah.
But my question is, if I do use a lacquer, what kind of lacquer to maintain durability for many years?
Yeah, the specific product, I worry whenever, I showed you the project in Bordeaux, and that was a lacquer, okay? A lacquer is a very general term as far as a coating material. So the idea of putting a lacquer on a lot of these precious metals, trying to preserve it, you have to be very difficult with any time you have the cut edges. That was a good example.
Conditions that we painted after cutting and not repainted the sheet.
Sure. So you're asking, I don't have a specific coating on it, but I do know that it is possible for copper, and maybe someone else from the group, Outokumpu, I mean, you know, any suggestion on Core 10 trying to maintain the color? I would personally be resistant for that particular metal because Core 10, it is a corrosion that you're seeing. It's not like a patina, like for copper or for zinc or for titanium. Those colors have a natural patina to them. It's hard to call the Core 10 corrosion a patina, if that makes sense.
And the last point, if I let the copper become green, which is the end of the corrosion process, will it stay stable or it still will come out with coloring to the surrounding?
I think if it was left under the normal process, it would stay that way. But that's why a lot of architects are interested in using these metals as opposed to paints. It's the same thing, Jim, we always talk about the difference between precast and limestone. You know, if you want it to look solid, you know, you would use precast, but a lot of times we try to use natural material, so the material takes on a texture. Okay, you're going to get that with copper. You're going to get that with limestone. You're not necessarily going to get that with precast, and you're not necessarily going to get that with a coated PVDF coating. These are just different coatings. Lastly, we do strive very hard on the metallic coatings to give the metal some life, you know, to give it a flake. It is, and that's what that coating's trying to do.
And the green end of the corrosion process, is it different when it's located inside an atrium and outside the exterior facade?
Oh yeah, I think in an interior environment it would be much slower. Is that your question?
So there will be a difference if the same wall is part of it is inside, part of we will see a difference.
Yes, you will see difference. And that's a very good example. If you have a facade where part of a facade is on the exterior element and part is on the interior element, definitely the interior is going to corrode patina at a different rate than the exterior, and that would have to be considered.
Even if we take the green end of the corrosion process?
The green is ultimately the end. At a certain stage, copper, like all these materials, they have a limited life. And for copper, it's a very long life. But ultimately, the product's gauge, how thick the material is also going to determine the life of the product. Ultimately, the patina that occurs at the last stage, the green, you know, it could last 100 years, you know, depending on its gauge.
If we are talking about metal and aluminum, and we are talking about the process of anodizing or liquid or some kind of paint. I'm talking about fabrication before or after the treatment of coloring. What is the recommendation about it when I cut it, when I bend it, after or before anodizing?
Yeah. Well, the best, a lot of people could speak to that. Definitely, one of the things you said was bending. And that's a very good. So typically, a lot of times you would say to paint the material before and then fabricate it. The problem with bending of it, the thinner materials, you're going to destroy the finish or you're going to change the finish. So thinner materials will have to be, you can break them and they maintain it. Like copings, we're always dealing with copings on our projects. Copings we have with a thicker metal, and because of that, they need to be coated after they've been broken. The Bordeaux is a great example. Ideally, all aluminum, as an example, for coatings, should be painted, coated after their fabrication. Is that true for all curtain walls? For sure it is not. Okay. Would it be preferred? Yes, it would. There's a cost implication. The Bordeaux example, what's interesting about it is they used a lacquer. A lot of PVDF coatings, you're not going to see that film form corrosion that we showed on that example because it's going to be behind the coating. The Bordeaux project was cursed with that transparency of the actual finish. It was a clear lacquer. A lot of times you might have that film form. Let's be clear, the film form doesn't really necessarily affect the structural properties of the aluminum, depending on its gauge. It's just the discoloration that they're rivaling. So in answer, ideally, metals are coated after they've been cut, but there are for economic reasons, there's loads of reasons why that isn't possible.
Thank you. I wanted just to emphasize, as much as I know, if you take PVDF liquid and you bend it after being painted in a radius bending of twice the thickness of the material, it's okay. But if you use anodize, my question, can you bend it after the anodize process?
Yeah.
Because you are limited in making anodize and liquid after bending because of the size of the panels and so on.
No, that's definitely true. We think of anodizing extrusions as an example, but I would say there would be a limit. The heavier gauge, you're going to discolor it. It's not going to maintain that same color. So a heavier gauge aluminum that's been anodized, if it's broken afterwards, you're going to see a discoloration. I mean, I know you are.
The title of this conference is Towards Sustainable Vertical Urbanism, and so we had a few words before the talk, and perhaps we should try and put this into a sustainability perspective. I'm particularly interested in the comments that were made during the talks about maintenance. So I'd like the panel to comment on how maintenance is considered during the design stages and how maintenance is actually carried out in practice, and also perhaps think about how the longevity of the facades plays into the decision making. So I don't know who wants to kick this off, but Patrick, and then the other guys can follow.
Well, one example I'll share with the group, which I thought was very interesting. It's fairly close to us. The bird's nest in Beijing is kind of touted as being a sustainable project because of the metal they chose. And to me, it was not obvious. I think it's a wonderful structure. And I think that, to your point, buildings that will last longer, more than 10 years, 100 years, these are sustainable concepts. So that would fall into it. But I thought it was very interesting. The bird's nest was designed with a very high-strength steel. So why is that sustainable? Well, it's because they use smaller members. And the smaller members use less natural resources. And those smaller members, when they put them on a truck and they transport them to the site, they use less fossil fuel. And I thought it was a very interesting concept. And I think all of us have to think about there's a lot of content. Everyone thinks that aluminum is so sustainable, and these maybe people from the industry would verify it. But I do think if you've got coated aluminum, that is not likely to be recycled back into our extrusions for strength reasons. Once the coatings have been contaminated, there's really a limitation, and there's enormous energy that goes into producing aluminum. So it's a very complicated question.
I know.
Of course, you might add stainless steel is supposed to be a sustainable material just because of that recycling issue, and we use the 85% recycled material for producing stainless steel usually.
And from experience, do you see cleaning of facades every 2 months?
No, of course not.
So I'm just flagging it as something that will ultimately determine the life of a building, that it's being looked after, that it's being loved by the people who own and use it.
But the every second month is the exception if you use the 316L in the Middle East. And usually it's not required. But that's probably not sustainable if you have to do it every second month.
Gotcha.
I had a question maybe going back to something you guys mentioned earlier in reference to Jeffrey's presentation and about data-driven and parametric design and its relationship to sustainability. I think that a lot of times we're limited in the conversation we're having or in the work we can do, not because of our design ability, but maybe because of some political concerns or other legal issues. We see that globally going on, that the sort of sustainability dialogues are dictated in large part by governments and politicians rather than technical people. But the question is, could you maybe, for those of us that might be more naive, just expose some of the particular challenges or issues that you were sort of secretly referring to in terms of data and this kind of thing? I think you mentioned it sort of just now a little bit, but perhaps we could just say openly.
My father's a lawyer, and I'm not. There's a reason for that. There's always a big debate around control of information. So, who owns the drawings, who owns the manufacturing, who owns the fabrication. And these clear delineations of ownership have been formulated over hundreds of years of legal precedent. And here we come with BIM models in which all of us are operating simultaneously in a rich three-dimensional environment, and nobody can figure out who owns what anymore. And you can imagine the lawyers go crazy. They're excited, they're dismayed, a lot of emotion. It's going to evolve, and it's probably going to evolve in the courts. Yep, that's how it happens. Again, I use North America as one system of resolving these kinds of debates. It's probably going to resolve itself over time, and it's going to resolve itself over time through litigation. That being said, if we can, again, all set up projects and processes, contracts, conversations and dialogue with our clients or with each other, we can at least help define this conversation as best we can outside of the courts.
I would like a comment from the panel about self-cleaning finishings. Now in the market there are some painting and glass that you can order with self-cleaning finish. Do you have a comment on that, of this new material or new finishings?
Sounds like a great idea. I think it's titanium oxide. Or, yeah.
That's right.
We've been hearing about the product, for 20 years, the self-cleaning glass. And I don't work for a company that sells the glass, so I'm not trying to sell it to anyone. I don't see it on a lot of facades. It is a coating, and like all coatings, if it's on the outside of the facade, it can wear off. So if you think you're getting self-cleaning glass for 20 years, you need to read your father's contract. The other material that I've seen self-cleaning is for concrete structures. There's a fairly famous project in Rome, Jubilee Church. And I visited it, and honestly, it looks just tremendous from the interior. But from the outside, to try to say it's uniform and self-cleaning, I don't know. I will just say to the group, I'm a little suspicious. With caution, I'd have groups trying the self-cleaning products. I'm not saying don't use them, just with caution. Use these products. Remember, they are coatings, they wear off, and if you think it's going to maintain a uniform appearance for the life of the building just because you paid a little bit more for the product, you might be disappointed.